Next concept, prime and composite numbers. So, what about prime and composite numbers? Already we discussed in 4th class. Again we recapitulate what are the prime numbers and what are the composite numbers. Here prime numbers, the numbers which is having 1 and itself as a common factor. So, that numbers are called prime numbers. So, the numbers which is having 1 and itself as a factors, that numbers are prime numbers. For example, 13. So, what are the factors of 13? So, 13 is divisible by 1 and itself. No other factor is there. So, 1 and 13. How many factors 13 is having? 1 and 13. So, this 13 is a prime number. Prime number means the number which is having 1 and itself as a factor. 1 and itself is a factor. Such numbers are called prime numbers. Prime numbers like 17. 17 is also a prime number. 17 is divisible by 1 and itself. So, 1 17 is a 17, 17 ones are 17. In other table we won't get this 17, in 2 table, 3 table, 4 table, 5 table. So, only in 1 table and 17 table we will get 17. So, it means 17 is having only 2 factors, 1 and itself. 13 is also having 2 factors, 1 and 13. So, like 7 also. So, 1 7 is a 7. So, 7 is having 2 factors, 1 and itself. 1 and itself. 13 is having 2 factors, 1 and itself. 17 is having 2 factors, 1 and itself. So, these type of numbers are called prime numbers. Prime numbers means the numbers which are having 1 and itself as a factor, they are called prime numbers. They are called prime numbers. Only 2 factors. Prime numbers are having only 2 factors. One is a factor for all the numbers, that is common, and another number is the number itself. It is having 2 factors, okay, 1 and itself, okay. So, like 13, 17, 9, 3, 5, 11, 19, all these numbers are prime numbers. Prime numbers are having 1 and itself as a factors, only 2 factors. Prime numbers are having only 2 factors, 1 and itself, 1 and itself. Next, all prime numbers are greater than 1. Why? Because greater than 1, 1 is neither a prime nor a composite number. 1 is neither be a prime nor be a composite number. So, one more condition, 2 is also a prime number. So, why? 2 ones are 2. So, 1 2s are 2. It divides 1 and itself, 2 is also a prime number. So, 2 is an even prime number. All even numbers are not prime numbers except 2. 2 is an even as well as prime number, okay. Other prime numbers like 4, 6, 8, 10, 12, other prime numbers, other even numbers are not prime number. Only 2 is a number which is even as well as prime number, but 1 is neither be a prime nor be a composite. These 2 bits you have to remember. What is that? The first bit is 1 is neither be a prime nor be a composite, and the second is the number 2 means 2 is an even prime number. 2 is an even prime number, that is even as well as prime number, okay. These 2 conditions you have to remember, okay. Next, what is a prime number? Prime number means the number which is having 1 and itself as a factors is called prime number. Then, about composite numbers. So, what are composite numbers? Composite numbers means the numbers which are having more than 2 factors, such numbers are called composite numbers. Suppose 4, 1 4s are 4, 1 4s are 4, 2 2s are 4, 2 2s are 4. So, how many factors we are having here? 1, 2, again 2 is there, do not take again this 2 and 4. 1, 2, 4, how many factors this 4 is having? This 4 is having 3 factors, 1, 2, 4. So, if any number is having more than 2 factors, that is a composite number. 2 means more than 2 means 3, 4, 5, 6, 7, whatever it is. This means if any number is having more than 2 factors, that is a composite number. Suppose 6. So, 6 factors, 1 6 is 6 first, then 2 3 is 6, again 3 2 is 6, 3 2 means again, so it is there 2 3 is again 3 2 it reverts order. So, do not take, you stop till here only. So, it is enough. Now, how many factors this 6 is having? 1, 2, 3 and 6, 1, 2, 3, 6, total how many factors? Total 4 factors. 4 is having 3 factors and 6 is having 4 factors. It means if a number is having more than 2 factors, the number is a composite number. Okay. Here prime number means the number which is having only 2 factors, 1 and itself. So, all non-zero numbers have at least 2 factors. So, that is there, all non-zero numbers having at least 2 factors, either it is a prime number or it is a composite number. Prime numbers are having 2 factors and composite numbers having more than 2 factors. It means the numbers at least they have 2 factors, they have 2 factors. Okay. So, these are the composite numbers, prime numbers and composite number. Okay. Next, twin prime numbers, twin primes. If any 2 prime numbers were there, in between one composite number is there, that 2 prime numbers are called twin prime numbers. Suppose 3 and 5, 3 is a prime number and 5 is a prime number. In between 3 and 5, one composite number is there. So, that is 4. If one composite number is there between 2 prime numbers, then the 2 prime numbers are called twin prime numbers. Twin prime numbers. The same way 13, 11 and 13, 11 and 13. This is 11, this is 13. 11 is a prime number and 13 is also prime number. In between these 2 prime numbers, we have one more number, that is a composite number, that is 12. 12 is a composite number between 11 and 13. 12 is a composite number between 11 and 13. So, 11 and 13, these are called twin prime numbers, twin prime numbers. In the same 5 and 7, these two are the prime numbers, 5 and 7. 5 and 7 are the prime numbers. In between these 2 prime numbers, one composite number is there, that is 6. If only one composite number is there between 2 prime numbers, then that 2 prime numbers are called twin prime numbers, twin prime numbers. Here 3 and 5 are the prime numbers. In between these 2 prime numbers, one composite number is there, only one composite number is there. So, these two prime numbers are called twin prime numbers, like 11 and 13. 11 and 13 are the prime numbers. In between these 2 prime numbers, only one composite number is there. So, 11 and 13, these 2 numbers are called twin prime numbers. In the same 17 and 19, 17 is a prime number, 19 is a prime number. In between 17 and 19, one composite number is there. So, these two are called twin prime numbers, twin prime numbers. Suppose 7, after 7, which one is the 11? 7 and 11, these two are the prime numbers. How many composite numbers are there? 7, 8, 9, 10. 1, 2, 3, 3 composite numbers are there. In between these 2 prime numbers, 3 composite numbers are there. So, that is why this 7 and 11, these 2 prime numbers are not twin prime numbers. Twin prime numbers means only one composite number should be there. Here 5 and 7, in between these 2 prime numbers, only one composite number is there. So, that is why these 2 numbers are called twin prime numbers. This is the condition for twin prime numbers. Okay. There should be a one composite number between the 2 prime numbers. Then that type of prime numbers are called twin prime numbers. Okay. First definition for prime numbers. Prime number, the number which is having only two factors, 1 and itself. So, that type of numbers are called prime numbers. Composite numbers, the numbers which are having more than two factors. So, that numbers are called composite numbers. Twin prime numbers. So, if in between two prime numbers, if only one composite number is there, then that two prime numbers are called twin prime numbers. Twin prime numbers. Okay. Next, co-prime numbers. What about co-prime numbers? Twin prime is different and co-prime is different. So in between, if any two numbers means composite number, either composite number or prime number, so whatever it is, so there should the common factor should, we have a common factor 1, then that number is called co-prime number. So here 3, first you take 3 factors, 1 3s are 3, no other factors we have, only 2 factors. In 4 we have 1 4s are 4 and 2 2s are 4, 2 2s are 4. Now 3 factors, what are 3 factors? 1 and 3, 3 factors 1 and 3, and 4 factors 1 2 4, 1 2 4. What are the common factors in between these two? Only 1. If only one common factor is there between the two numbers, then that numbers are called co-prime numbers. Co-prime numbers. In the same here 4 and 9, check. So 4 factors, 1 4s are 4, 2 2s are 4. Okay. 9 factors, 1 9s are 9. In 2 table we won't get 9. In 3 table, 3 3s are 9, 3 3s are 9. Then 4 factors. What are 4 factors? 1 2 4, and 3 factors 1 3 9. So what are the common factors in between these two? What is the common number between common factor? 1 is common in between these two. No other number is common between these two. Only 1 is common. So if only 1 is a common factor in between the numbers, then that type of numbers are called co-prime numbers. Co-prime numbers. Co-prime number means common factor in between the numbers, in the given numbers only 1 is a common factor, then that type of numbers are called co-prime numbers. Co-prime numbers. These are the definitions for prime numbers, composite numbers, twin primes and co-primes. Okay. Prime numbers means the number which is having 1 and itself as a factor, they are prime number. Then the second one, composite numbers, the number which is having more than 2 factors, that number is called composite number. Then twin prime numbers, so in between 2 prime numbers only one composite number is there, then that 2 prime numbers are called twin prime numbers. Then co-prime numbers. Co-prime numbers means if common factor between the given number is 1, that numbers are called co-prime numbers. Co-prime numbers. Okay. Factorize. Prime factorization method. What is prime factorization method? Prime factorization method means whatever the number is given, so that number we have to write in the form of, in the product of prime numbers. In the product of prime numbers. That is called prime factorization method. Whatever number is given, so and so. Here it is given 56. This 56 number we have to write the product of prime numbers. So here various methods were there. So one method is factor tree method, other method is division method. In two various method, how to write the given numbers into product of prime numbers. Product of prime numbers. First, here what is the number given? 56. This 56 we have to write in the form of tree method. 56 first. Take 56. Now this 56 you have to split into product of two numbers. So that is your wish. 7 8s are 56. 7 8s are 56. So product of two numbers. Here 7 is a prime number. So further we can't split this number. Okay. Then 4 is a co-prime number, we can split. Then split this number again. 8 means 2 4s are 2 4s are 8. Here 2 is an even prime number, we can't split this one. Again, so this 4 is a co-prime number, composite number, then we can split this number again. So then how? 2 2s are 4, 2 2s are 4. Now once you check, here 2 is an even prime number, here 2 is an even prime number, here 7, 2, 2, 2, all these are prime numbers. Now, so how to take this one? 56 as a product of prime factors, prime numbers. So this is 7, so 7, so like this we have to move, 7 into 2 into 2 into 2. Now 2 2s are 4, 4 2s are 8, 8 7s are 56, 8 7s are 56, 8 7s are 56. It is not 58, this is 56. Okay, 56. So all these numbers are prime numbers. 7 is a prime number, 2 is a prime number, 2 is a prime number, 2 is a prime number. So this 56 we are converting into product of prime numbers. This is called prime factorization method. So this is prime factorization method. All are prime numbers. All are prime numbers. So this is 56 we are converting into product of prime numbers. So this is called prime factorization method. Okay. So this is the method is tree method, factor tree method. So like branches we have to do. So like tree branches. So this we have to consider as branches. So first branch, second branch, third branch, like this. Okay. So that is why it is called tree method, factor tree method. Okay. Now the second one, division method, prime factorization method by using division method. Then how to do? Using division method. So first of all, so what is the number given here? 340. This number we have to write, say, in the product of prime factorization method using division method. First you take 340. Now you take like this. Now first you check whether the given number is even number or odd number. So here the last digit is 0, it is an even number. When the number is even, then go for 2. Divide with 2. First divide this 3. So when you will get 3 in 2 table, 2 ones are 2, 2 ones are 2, here 3 is there, 2 3, between how much gap is there? 1 gap is there. Here it will get 14, it will get 14. Now where you will get 14 in 2 table? 2 7s are 14, 2 7s are 14, and this 0 as it is. Then after that again, so once you check either this number is even or odd. So what is the last? Means ones place 0. In ones place 0 is there, so it is an even number. So again divide with 2. When you will get 17 into 2 8s are 16, 2 8s are 16, 16 and 17. So what is the difference? One difference, that one you keep here. So it's 10. Now it's 10. Then when you will get 10 in 2 table, 5s are 2 5s are 10. Now it is 85. Now after this, once you check what is there in units ones place. In ones place 5 is there. If ones place 5 is there, that means it is divisible by 5. Divisible by 5. Then take 5. So when you will get 5 in 8, when this 8 will get in 5, 5 ones are 5. Here 8 is there, 5 and 8. How much gap is there? 3, 35. That means 5 7s are 35. Now here 17. 17 is a prime number, no need to take. So leave it. Okay. When it is a prime number, it is a prime number, no need to check in other tables. Why? Because this is a prime number. Prime numbers are divisible by 1 and itself only. So no need to check this prime number. Okay. First how to divide? So once you see here, first you take whatever the given number is there, that given number we have to take here. Now after that, so once we check the given number is even number or odd number. If it is an even number, then so we have to divide with 2. So, here in unit place 0 is there, it is an even number. So, divide with 2. 2 ones are 2, here 3 is there. 2 and 3, between 2 and 3, what is the difference between 2 and 3? 1. So, that difference we have to keep here. So, we get here 14. After that, when you get 14 in 2 table, 2 sevens are 14. 2 sevens are 14, then after this 0 is left, this 0 as it is we have to keep. And after that we have to check this number, either this number is even or odd. This number is even number. Why? In one's place 0 is there, so even number. So, again we have to divide with 2. 2, when you will get 17 in 2 table, 2 8s are 16, 2 8s are 16, 16 and 17, difference is 1. So, that one difference we have to keep here, so we get 10 here, and 2 5s are 10. Then after that, so one's place again we have to check here, 5 is there. If in one's place, if 5 is there, then that is divisible by 5. Then take 5, 5, when you will get 8 in 5, 5 ones are 5, 5 and 8. What is the difference between 5 and 8? 3. That difference we have to keep here, so we get here 35. When you will get 35 in 5 table, 5 sevens are 35. Then after that, this 17 is a prime number. Prime number is divisible by 1 and itself, so no need to check in other tables. Why? Because it is not divisible by in any other table. So, stop till here only. Now, 340, the product of prime factors. Product of prime factors. 2 into 5 into 17. 2 into 5 into 17. So, this is the answer. This is the method using factor tree method. This is division method. Okay, two various methods we are using to do these sums. By using factor tree method and division method, we solve prime factorization method. For prime factorization method, so two methods were there in that. One is tree method, another one is division method. Okay. In exercise 3rd, see here, find the prime factors of each of the following numbers using factor tree method. Factor tree method we have to use. Here 81. First we have to divide this 81, the product of two numbers. 9 9s are 81. 9 9s are 81. 9 9s are 81. Again this 9 we have to split. So, how product of two numbers? 3 3s are 3 3s are 9. Again this 9 also we have to split. 3 3s are 9. See here, this is 3, here 3, here 3, here 3. So, all these 3's are prime numbers. Then further we can't split this number. So, now 81 is equal to product of prime factors, 3 into 3 into 3 into 3. In this way we have to split and we have to do. Okay. Now 256, 256. Then this is an even number, then how to split? So, first this 256 is divisible by 2. 2 128s are 256. 256. Again this 2 is a prime number, then we have to split this number 128. Then in 2 table again 264s are 128. Again this 2 is an even number, again we have to split this even number. 2 32s are. Again this 32 again we have to split. Why? Because this is a prime number. 2 is an even prime number. So, 2 16s are. 2 16s are 32. Again this 16 we have to split. 2 8s are. Again this 8 we have to split. 2 4s are. Again this 4 we have to split. 2 2s are. Now, it is enough. Now, then how to take this 256? 256 product of prime factors. 2 into 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 2. How many 2's? 1, 2, 3, 4, 5, 6, 7, 8. 8 times we have to take. 2 into 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 2. Okay. So, in this way we have to write the product of prime factors using tree method. Okay. Now, here find the prime of each of the following numbers by using division method. So, here we have to use division method. First we have to take 66. So, it is an even number. So, it is divisible by 2. 2 3s are 6, 2 3s are 6. Again here this is 33, it is an odd number. It is divisible by 3, 3 11s are 3 11s are. So, 11 is a prime number, no need to check further. So, why? Because the prime numbers are divisible by 1 and itself. Then 66 is equal to 2 into 3 into 11, 2 into 3 into 11, all are prime numbers, product of prime numbers, product of prime numbers. Now 112, 112, it is an even number, so divisible by 2, 2 5s are 10, 2 6s are 256 are 112. Again this 56, 6 is an even number, so this is 56 is an even number, it is divisible by 2, 228s are. Again this is an even number, so it is divisible by 2, 214s are. Again it is an even number, divisible by 2, 2 7s are. 7 is a prime number, no need to check further. Okay, stop till here. Now 112, 112 product of prime numbers, 2 into 2 into 2 into 2 into 7, 2 into 2 into 2 into 2 into 7. So, all these are prime numbers, so product of prime numbers using division method. This is division method, this is tree method, factor tree method, this is division method. In these two questions, one more question is left in both, in first bit and in second bit, that you do as your home assignment. Okay. Now, the third one, fill in the blanks. The first blank, dash is neither a prime nor a composite number. Which number is neither a prime nor a composite? 1. 1 is neither be a prime nor be a composite. Before we discuss. So, when the concept is going on, which prime numbers? So, prime number 1 is neither be a prime nor be a composite, and dash is only even prime number, that is 2. 2 is only the even and also prime number. Other even numbers are not prime number, not prime numbers, only 2 is an even prime. Okay. So, 1 is neither be a prime nor be a composite, and 2 is only the even prime number. Okay.